Hi everyone, and welcome to the first video of this unit, which covers compression, encryption, and hashing. This is part of Unit 4, where we'll delve into the intricacies of data exchange. Throughout this video, we'll explore various methods and techniques used to manage and secure data efficiently. Let's start by outlining our objectives for this session. By the end of this video, you should be able to differentiate between lossless and lossy compression techniques, understanding how each method reduces file size and the trade-offs involved. Describe the principles of run length encoding and dictionary-based compression methods, learning how these techniques work to compress data. Define and differentiate between symmetric and asymmetric encryption, exploring how these encryption methods secure data, and explain the role and application of hashing in data encryption, understanding how hashing ensures data integrity and security. Data transfer and storage are fundamental aspects of computer systems and networks. Data is constantly being moved around within these systems, and this transfer is typically rapid and precise. However, as the distance over which data is transferred increases, the speed can decrease, and the risk of interference can rise. Additionally, storage space can be a limiting factor, necessitating efficient data management techniques. Consider cloud storage services like Google Drive and Dropbox. These platforms rely on efficient data transfer and storage to provide seamless access to files from anywhere in the world. Understanding how data is transferred and stored helps us appreciate the importance of compression and encryption in maintaining efficiency and security. Reducing data requirements is crucial for efficient data management. Text, images, and audio data can be significantly compressed to reduce their size. This compression offers several advantages. Faster data transmission, which is essential for timely communication. Reduced bandwidth usage, which is crucial when transfer limits apply. Decreased likelihood of buffering in audio and video streams, enhancing user experience. Lower storage space requirements, which is vital for managing large volumes of data. Streaming services like Netflix and Spotify use compression to deliver high-quality content with minimal buffering and reduced data usage. This ensures that users can enjoy their favorite shows and music without interruptions. There are two main types of compression, lossy and lossless. Lossy compression, this is a method that permanently removes non-essential data, such as similar colors in images or inaudible sound frequencies to reduce file size. While this results in a smaller file size, some data is lost in the process. With lossless compression, this method identifies and summarizes data patterns without losing any information, allowing the original data to be perfectly reconstructed. Although the file size reduction is less significant compared to lossy compression, no data is actually lost. JPEG images and MP3 audio files are lossy compression to reduce file sizes, making them easier to store and transmit. On the other hand, zip files use lossless compression to ensure that no data is lost during the compression process. Let's look at some examples of lossy compression. When we look at JPEG, for image compression, this method permanently removes data to reduce file size. It attempts to reconstruct the image without the missing data. This is why JPEG images are smaller in size but may lose some quality. MP3, which is an example of an audio compression, this method removes inaudible sounds and quieter notes played simultaneously with louder sounds to reduce file size. This allows for smaller audio files that still sound good to the human ear. Social media platforms like Instagram and Facebook use JPEG compression to quickly load images on users' feeds, ensuring a smooth and fast user experience. Lossless compression works by reducing data patterns. Lossless compression works by recording data patterns instead of the data itself, allowing exact replication of the original file without any data loss. Although this method is less effective in reducing the file size compared to lossy compression, it is ideal for compressing text files and software code where data integrity is crucial. Software developers use lossless compression to distribute software updates without any loss of data, ensuring that the software functions correctly after decompression. Run length encoding is a basic compression method that summarizes consecutive patterns of identical data. This technique is particularly effective for compressing image and sound data with repeated patterns. For example, in an image with large areas of the same color, RLE can significantly reduce the file size by recording the color and the number of consecutive pixels of that color. Fax machines use RLE to compress scanned documents for transmission, reducing the amount of data that needs to be sent over the phone line. In sound recordings, many samples are taken per second, typically 44,000. If the same sound or note is played for a fraction of a second, it could result in hundreds of identical samples. RLE records one sample and its repetition count, significantly reducing the data size. For example, a sustained note in music could be compressed by recording the note and the duration it is held. RLE is used in digital audio formats to compress repetitive sound patterns, making audio files smaller and easier to store and transmit. Dictionary compression identifies frequently occurring data and stores it separately in a dictionary. References to dictionary entries are then used to reduce the original data size. Despite the additional overhead of maintaining the dictionary, the space savings are substantial. This method is particularly effective for text data with many repeated words or phrases. Web browsers use dictionary compression to reduce the size of web pages, speeding up loading times and reducing data usage. Let's look at an example of dictionary compression. Consider the phrase "no pain, no gain." By splitting the phrase into repeated words or characters and storing them in a dictionary, we can reduce the data size. For instance, "no" and "pain" can be stored as dictionary entries, and the phrase can be compressed by referencing these entries. Text editors use dictionary compression to reduce the size of documents, making them easier to store and share. When dealing with larger volumes of text, dictionary compression can be particularly effective. For example, in a text document, each letter could be stored as an ASCII code of 8 bits. By storing frequently used words in a dictionary and assigning them shorter binary codes, we can achieve significant space savings. For instance, the word because could be stored as a single dictionary entry, reducing the data size for each occurrence of the word. Email services use dictionary compression to reduce the size of email attachments, making it easier to send and receive large files. Encryption is a method of ensuring that data cannot be understood without decryption. Plain text, or the original message, is encrypted into ciphertext using a cipher algorithm and a key. When the ciphertext is received, it is decrypted back into plain text using the same or a different key. Encryption is essential for protecting sensitive information from unauthorized access. Online banking uses encryption to protect sensitive financial information during transactions, ensuring that your data remains secure. The Caesar cipher is one of the most basic and insecure encryption methods. It works by shifting the letters of the alphabet by a consistent amount. For example, if we shift each letter by 3 positions, A becomes D, and B becomes E, and so on. While simple, the Caesar cipher is easily broken with modern techniques. The Caesar cipher is a historical encryption method used by Julius Caesar to protect military messages. Although it is not secure by today's standards, it provides a good introduction to the concept of encryption. A brute force attack attempts to decrypt ciphertext by trying every possible key until the correct one is found. This method can be time consuming, especially when more complex encryption algorithms are used. To make decryption more difficult, spaces are often removed from the ciphertext to mask word lengths. For example, let's try to decrypt the following ciphertext using brute force. Cybersecurity professionals use brute force attacks to test the strength of encryption methods, ensuring that they are robust enough to withstand unauthorized access. Frequency analysis is a technique used to break simple substitution ciphers by analyzing the frequency of letters in the ciphertext. In English, certain letters are used more frequently than others. For example, E is the most common letter, followed by T, A, O, I, N, S, R, and H. By comparing the frequency of letters in the ciphertext to these common frequencies, we can make educated guesses about the plaintext. Cryptanalysis uses frequency analysis to break simple substitution ciphers. This technique was famously used during World War II to decipher enemy communications. The Vernam cipher, also known as the one-time pad, is the only encryption method proven to be unbreakable. It uses a key that is a truly random sequence of characters, longer than the plaintext, and used only once. The key must be shared with the recipient independently of the message and destroyed immediately after use. This ensures that the ciphertext cannot be decrypted without the key. The Vernam cipher is used in high security communications, such as diplomatic and military messages, where absolute security is required. Encryption and decryption with the Vernam cipher are performed bit by bit using an exclusive OR operation with a shared key. For example, if the plaintext bit is 0 and the key bit is 1, the resulting ciphertext is a 1. If both bits are the same, the resulting ciphertext bit is 0. This process ensures that the ciphertext is completely random and cannot be decrypted without the key. The exclusive OR operations are used in various encryption algorithms to ensure data security. This method is fundamental to the operation of the Vernam cipher. The one-time pad must be truly random, generated from unpredictable phenomena such as atmospheric noise, radioactive decay, or the movement of a mouse. A truly random key will render any frequency analysis useless, as it would have a uniform distribution. It's important to note that computer-generated random sequences are not actually random and should not be used for one-time pads. One-time pads are used in secure communications where absolute security is required, such as in diplomatic and military contexts, as mentioned earlier. Ciphers are based on computational security, meaning that the keys are determined using a computer algorithm. While these keys can be very secure, given enough ciphertext, computational power, and time, any key, except the one-time pad, can be determined and the message cracked. This is why it's important to use strong encryption algorithms and keys. Modern encryption algorithms like AES, or Advanced Encryption Standard, and RSA rely on computational security to protect data. These algorithms are widely used in secure communications, online transactions, and data storage. Symmetric encryption, also known as private key encryption, uses the same key for both encryption and decryption. This means that the key must be transferred to the recipient securely. However, this poses a security risk, as the key can be intercepted as easily as the ciphertext message. Symmetric encryption is used in secure file storage and data transfer. For example, the AES algorithm is commonly used to encrypt sensitive data on hard drives and in secure communications. Asymmetric encryption uses two separate but related keys, a public key and a private key. The public key is made public so that others can use it to encrypt data intended for you. However, the public key cannot decrypt the data. Only the private key, which is known only to you, can decrypt the data. This method ensures that even if the public key is intercepted, the data remains secure. Asymmetric encryption is used in secure email communication and digital signatures. For example, the RSA algorithm is widely used to secure data transmitted over the internet. Hashing is a process that provides a mapping between an arbitrary length input and a usually fixed length or smaller output. It is a one-way function, meaning you cannot get back to the original input from the hash. This is useful for storing encrypted pins and passwords so that they cannot be read by a hacker. To verify a user's password, the software applies the hash function to the user input and compares the hashed result with the other one stored. Hashing is used in password storage, ensuring that even if a database is compromised, the actual passwords remain secure. Common hashing algorithms include SHA-256 and MD5. To summarize, compression and encryption are essential techniques for managing and securing data. Compression reduces the size of files, making them easier to store and transmit. Lossy compression is most effective at reducing storage space, while lossless compression maintains the integrity of the original data. Encryption obscures messages to protect data from unauthorized access. Symmetric encryption uses the same key for both encryption and decryption, while asymmetric encryption uses a pair of keys. Hashing provides a secure way to store and verify passwords and other sensitive information.